thank you for tuning in. Welcome to a new episode of the Passion for Technology podcast by EBB Electronic.
Welcome to the Passion for Technology podcast. Everything is going digital and has been for years, but there is one issue that gets marginalized all too often. Today's episode is all about analog integrated circuits. That's analog ICs for short. What do you need them for? How are they associated to digitalization? We'll be talking about these and more questions with our guests. Tarek Swebes is joining us from ST Microelectronics, where he is a technical marketing director. Hi, Tarek.
Good afternoon.
Milan Ivkovic is Director Segment in Analog Power at EBV Elektronik. Hi, Milan.
Hello.
Well, welcome to the show, Milan and Tarek. I have a couple of basic questions. Well, the first one being, what are analog ICs, Tarek?
Good question. I think, let me start to tell you that you can find many different definitions of analog, depending on who you ask. But for me, analog circuits are devices that work in a linear way and process continuous data. I don't think it will be the only answer, but what I can share additional to that is currently we have a trend to integrate more and more digital components into analog IC. But we should not forget that every sensing task starts with some analog measurement that can be later on encoded and displayed as a digital value.
Yeah, I would have to agree completely with Tariq on this answer. And I would also add on the top of that for the audience who is not maybe familiar with digital stuff, so analog design is really the basic layer even of digital circuits, because if you take example of simple logic inverter, we have to design it in analog way because we have to take a look at continuous signals. We have to check all the design and check all the logic levels, driving cars, etc. And we have to involve all boundary cases, process parameters variations, temperature variation, and so on. And when then naming just examples of analog ICs, then it would be a class of devices like amplifiers, comparators, level shifters, power controllers, and similar devices.
So both of you have already mentioned a couple or a number of examples, actually. Could we dive a little deeper into that? What are analog semiconductors needed for? Where do they get used?
Well, if I start answering, as Tariq already mentioned, wherever we have a boundary of our electronic system with the physical environment, we need analog. We need analog in signal acquisition to interface different kind of sensors that will interface physical measuring. And on the other side of the system, we need to drive actuators, whether it is valve or a motor, to be able to control some other physical stuff. So in between, there are a lot of communication interfaces. There are some power controllers, power managements, communication equipment like modulation, demodulation, looking at the functionality side. But when we take a look at the application side, areas that are very intensive in analog and power devices use are like industrial automation, motor drives, robotics that is very popular today, personal health devices, and so on.
You already mentioned how analog is more or less the only way to go in certain areas. So how would you gauge whether analog and digital ICs are, either in competition with each other, or are they usually complementary to each other? Milan, what do you think?
So, as we say, there are many, many ways to describe this or to divide this in different issues to be solved. But as we mentioned, anywhere where we have a contact to physical world, analog is inevitable. And on the other side, wherever we have digital signal processing, storage, then digital is something that is really in focus and, let's say, inevitable. And in between, we have number of functionalities where both analog or digital approach can be used. For example, on the other hand, we have to think about the overall cost of the system. So it means that we have to make some trade-offs. And also we have some examples in power conversion, like if you take just the example of PFC controller. So in some cases, it would be really nice to use analog PFC controller that would take a burden of any control loop design. But on the other hand, if we have MCU in the system, we will maybe wish to design our control loop inside MCU and then add some additional features, have some flexibility, or save at least some dollars at the end in the design.
Tarek, would you say that analog technology is benefiting from digitalization? I mean, how's the market developing there?
I think we have there a quite interesting situation. because due to the increase of digitalization that is everywhere and demand for connectivity to transmit data, a lot of sensors are used. Let's take one of example in the industrial world, smart factories, where it is required to sense a lot of parameters from sensors. Data, you can think such of a vibration reflecting health of a machine or any current that would need to be measured in a motor control. Therefore, analog technology is indirectly benefiting from digitalization in some way. There is also the case of automotive that is very visible today with the car electrification that is requiring usage of a lot of sensors, current sensor or a pump to amplify analog signal. And the market trend is to go for a higher level of integration, but at the same time, there is a certain level of simplicity and performance that we can only obtain with the usage of analog.
Milan, taking a bird's eye perspective, which industries and applications are a particular focus?
Yeah, so we are now always repeating IoT for sure. Definitely IoT is something that is impacting because we want to have a lot of devices that are somewhere connected, that are measuring something. So here we need first analog signal acquisition and processing, whatever it is. And then we need for sure power management. And we see a trend also for a lot of devices that are lifetime battery, even no battery. So power management and consumption is really key. We can see a lot of electrification in automotive and autonomous vehicles. So definitely a lot of potential for analog and power stuff. Industrial with Industry 4.0, increase number of sensing nodes that are connected. Robotization, a lot of robots running around that are autonomous, so they had to do some power conversion in it. And finally, of course, 5G that is bringing new opportunities for analog and power stuff.
I mean, analog circuits have been around for at least 50 years. Tarek, when I asked you about, the benefiting from digitalization, are there still developments on the technology side of things?
Yeah, you're right. I want to tell you that first, we still have IC that can be considered as old because they are alive since 20 years and they will continue to be alive. This is important. They are very popular. This is what we call in ST our standard product. But in addition, we have new technologies like BCD or HCMOS. I don't want to go too much into details, but are the technology that allow us to bring innovations through the analog. For instance, we are increasing the operating input voltage for our step-down converters, as we do for our unidirectional and bidirectional current sense, the TSC family. We are also releasing the Type-C sync controller offer. Currently, the Type-C connector is popular in a lot of devices. And these are the technologies that are helping us to go further with the analog.
Milan, you mentioned electrification of mobility, IoT. Where do you see a particular potential for future development beyond that?
So when mentioning electrification, especially going to electric vehicles, power conversion is here really important topic because then a lot of power coming from internal combustion engines. Now everything is converting electrical energy actually from the battery or any energy storage element to the engine. So here there are a lot of potentials, and not just because of the electrical vehicle that has now electrical engine. There is electrification that with a lot of autonomous driving and a lot of sensors that are around and communication. So there is a high potential. And also we can see that in these personal devices like health devices or wearable, of course, technology is enabling for different kind of acquisition of signals around us or our body. So there is also huge potential, especially for power management and low power analog.
And which developments do you personally find most exciting if you'd had to select?
I would be on the side of energy conversion. So new technologies of wide band gap semiconductors, gallium nitride and silicon carbide. Definitely that is enabling highly efficient power conversion in high power applications. And one field that is maybe still niche, but I hope that it will be really broad in the future, it's energy harvesting. As I mentioned, with a lot of devices that are installed in the fields, like sensing nodes, this is a really great user experience, let's say, from the maintenance point of view, that you simply put your device and forget it for the lifetime because it can harvest the energy from the sun, from wind and so on.
Tarek, what about you?
I'm in full agreement with Milan. SiC and GaN transistors are really a breakthrough in the technologies, and they are impacting the analog. First, they are allowing us to go further in the power conversion with higher efficiency, increasing the power density. But then it is pushing us to develop drivers, because without the drivers, you cannot drive those transistors that are very efficient. So there is a clear link of the contribution from the analog side, because without the drivers, there is no way that can elaborate these new applications.
How do the electronics designers, the people who install analog ICs in their products, benefit from the new technologies, Tarek?
Well, I would say the new analog IC are usually optimized and developed for specific targeted application. They are bringing more robustness, higher precision, or any additional features, allowing the designer to focus more on the rest of his applications. So at the end, using analog will be a way for him to go for simple design and go for a shorter time to market.
Let's take a look into the future again. What role will analog ICs play in the future? Maybe a little further out. I'm especially interested in terms that you already touched on. Milan, you did with IoT and sustainable energy.
As we mentioned, actually, without analog circuits, we cannot make the electronic system complete. We have to interface outside world. We have to convert energy. We have to enable communication. And as Tariq said, I think that future developments of analog technologies have to go into direction to enable integration of more analog functions in a single chip. So to offload system level or board level designers from complex analog tasks. And at the end, analog is complex to design. And today we have a very good and efficient IC design tools that are helping solve all the issues. And I would say much more better than on a PCB level. So it's good to have a lot of stuff integrated. It's good to be integrated with the digital because it enables configuration, flexibility of the circuits. But on the other hand, what is a task is that we have to be sure that future technologies will enable that analog development inside ICs has the same development cycle as digital and to have the same success rate, let's say, to lower the number of failures on the chip itself. So these are all the challenges, and I think these are directions where we have to go.
Tarek, what's your take from a manufacturer's perspective?
It's clear for me, the role of the analog IC are pretty clear. They need to sense what we have around the environment. They have as a mission to contribute to improve the efficiency, for instance, in motor control, concrete application, improve the power conversion, better answer to what we are all looking at, sustainable, to be sustainable, energy efficiency, reduce energy consumption. This is where analog will continue to play a key role in the electronic life. This is really the key impact of the analog, not only in functionality, but also the role that analog is playing, analog product.
I found this very interesting. Thank you both for the insights that you've shared with us today. Tarek, Milan, it's become sort of a tradition with our show that at the end of each episode, we ask our guests about where the origins for your passion for technology lie. So, Tarek, I'd love to know when and how you developed your individual passion for technology.
A long time ago, because first I believe in people, people that are transmitting, sharing their knowledge. And at that time, you have, I hope it is the case for a lot of people, to have great teachers that are transmitting you, that are sharing their knowledge, explaining with the right words, motivating you to go further, to learn. And personally, I had this pleasure to have great teachers that are transmitting you this knowledge. And this was about the physics. And this is how I started going later on material for semiconductors. And this was the starting point. And I have absolutely no regret because this is really motivating with a lot of innovation, a lot of technologies. And it's a wonderful world. We are really lucky.
Milan, what about you? When did you and how did you develop your passion for technology?
Yeah, so I would say long time ago, going back in primary school, where I was really fascinated about mathematical problem solving, which was really, I can say, fascination about abstract problem solving. Then it was articulated later on during my electronic engineering studies, where I had opportunity to really design stuff to create something from scratch. And then this was like some kind of fascination about creation. And this allowed me to work with a lot of great people in great teams where I actually realized how we can and how we must collaborate together to achieve great things and to make great things working. And lately, in the maybe past few years, I'm thinking about how technology is helping us, our lives being better. I'm not referring to really basic daily routines like entertainment, where we are buying electronic products which are becoming waste in 1 or 2 years, or driving electrical cars where we are lowering emission here in my city, but it is actually maybe disaster or pollution in some other corner of the world. I'm talking about how technology can help our society to be better and how can we leave good heritage for future generations to come.
I find it very interesting that both of you, when explaining the sources for your individual passion for technology, actually mentioned people and relationships to people and bridged, your technological passion for technology to people in the real world, kind of like analog ICs probably do with the real world. Dear listeners, if you'd like to get in touch with either Tarek or Milan, feel free to reach out to them on LinkedIn. Also, there's a part of the EBV.com website that is dedicated to analog and power. We're providing links to EBV.com and STMicroelectronics in the notes to the episode. Please feel free to subscribe to our podcast, Passion for Technology, on either Spotify, Apple Podcasts, or any of the other popular podcasting platforms. Tarek, Milan, thank you for joining us today. This was very, very insightful.
Thank you.
Thank you.